My name is Dr. Nancey Tsai. I am a clinical assistant professor over at the Medical University and also a medical consultant for forensic medical reviews. These are my notes on innovation. I received my medical degree back in 1998, and I went through a very long way, but eventually finished at Stanford Physical Medicine and Rehabilitation in 2006. And so I've been in practice since then. I'm from Seattle, Washington.
How did you find yourself eventually here in South Carolina?
Well, I was born overseas in a tropical area, and this is about as tropical it gets in the United States. The weather, the storms, the fact that I have to carry a tide chart, because Charleston turned into an island, when the crosstown floods, all of those things. I'm a Southerner. I start at about 5 in the morning, and I have my personal time, which involves a little bit of journaling, meditation to find my space and decide what I want to create that day. I take my son to school. Then it's just a matter of tasking through the things that I feel I need to get to. The non-negotiables, I have to exercise, I have to stretch, have to do an inversion, and I guess at some point I have to eat too. But yeah, pick him up and get through my day. It's pretty free form these days. I've elected not to be in practice anymore. And so depending on what assignments come up is when I deal with them.
Meditation and journaling, is that something that was recent for you, or have you always done that? How did you get into that?
I started doing that when I was in the middle of my divorce. It was a self-centering activity I needed to get to because I needed to find that strength to go through the process. But it had actually really good side effects, and I feel like I'm happier and more effective now because of that. Exercise is non-negotiable. I think that if you were to find the most successful people in the world, they'll all tell you the first thing they do is they work out. And it's just not negotiable. What I do I don't do the same workout every day. I try different things. I've been in martial arts. I've tried running. I've done triathlons. I've done yoga. I'm going to start Pilates this year. Just trying something different all the time, and it keeps me physically and mentally agile.
Did you know that you wanted to be in medicine growing up?
Well, and when you first start, when you say it, you like the idea of doing it, right? But you don't really know what's all involved. The first time I was asked what I wanted to be, I think I was about 3 or 4, and I told them, I said, I'm going to be a doctor, and in a different language. And they said to me, girls don't become doctors, they become nurses. And I looked at them and I said, I'm going to be a surgeon. And I got derailed. I went into radio broadcasting for a bit for fun. It wasn't so much a career, it was just more for fun, and I did make a little bit of money at it. But eventually I kind of circled back around and said, I need to do medicine. It challenges me. It makes a difference. When you go through the process of medicine, do you really know what that road looks like? I think that's very personal to each person and probably to the population, and to a certain extent the constraints that are put upon us. It used to be that physicians were also small business persons. As we grew, we found out that there are certain quantums of practices. The solo practitioner takes on a lot of overhead costs. And so what you have are these small groups because they're able to consume a certain amount of resources effectively and efficiently. But then once you move into the next quantum and you start 4 to 7 and then you go into the 20 to 30-ish, then they can own their own building, have their own human resources, and just employ a bigger space. There's these little quantums of practices. And we've sort of figured that out. Are there innovators? Sure, there are. And how do they innovate? Do they innovate in the space by being more efficient in their practices? Or do they create new technology that makes a difference? And how does that come about? I have to say that mine kind of came about as an accident. I file a lot of useless knowledge away in my head, which means you don't want to play Trivial Pursuit with me. But regardless, I can actually string that and figure out, well, what can I do with that? How can I use this piece of information to slightly differently, but in a positive way that makes a difference? I don't really think that a lot of people, that's not the way they practice. But for those people who want to be a little bit creative, there is a little bit of that space to create, and you just have to find the right team to support you in that process.
Let's talk about the Blink Reflexometer. Can you talk about the vision there, how that came about?
When I first started in medical school, I was part of a research team in a plastic surgeon's office. She was doing nerve transpositions. And so I was listening to a couple of the guys who had to rate these blinks, the symmetry of the blinks. And it was difficult. And I said, well, can't you break down the frames? And they said, no, it's VHS. Betamax just beat out VHS, and we haven't figured out how to deal with this. And so if you rated it too high, it's not accurate. If you rated it too low, then your primary investigator gets mad at you. Well, you need a metric, something that she cannot argue with, and something that you can present so that the peer reviewer says, okay, this makes sense. So I filed that away. Well, fast forward about 10 years, and the iPhone came out, and digital photography came out, and Kodak went away, sort of. And what you saw was you could see discrete frames. You could count the blinks. You could count how many seconds it took to do something. And so, again, filed that away. That technology had to wait, though. Additionally, I just noticed that as I was going through, the anesthesiologist would always test the blinks. Well, why is that? That's a marker of your consciousness. So, file that piece away. I went to Stanford to do physical medicine and rehabilitation, and we have to do EMG as part of our rotations. I didn't actually do any Blink EMGs, but I did have to study it. It was on the board. We had to know something about it. And as I was going through it, it was actually kind of fascinating. I found myself sort of perseverating and reading a little bit about it. And I watched people, especially brain injury, on the brain injury unit. You get to see a lot of people walking through and just watching their reflexes. They definitely change. And it's all in the eyes. The anoxic brain injured person, sort of had this wide-eyed look. And the people who sustained other types of brain injuries, they had a very droopy eyelid look. And universally, I would say that their blink rate decreased. And if you were to stimulate them, they weren't quite as responsive, but I couldn't really put my finger on it. Again, I needed that metric. I didn't have the technology yet. And so all of these little pieces that I had filed away basically couldn't have happened until technology was invented that made it easier. I just packaged it nicer, I guess. I translated the EMG blink into something that you can take everywhere. And this is important here. Why don't we just haul the EMG out onto the field? I mean, come on, if this works so well, why wouldn't you just do it? The problem is EMGs need to be performed in a very strict parameter. The rooms can't have fluorescent lighting, for example. Fluorescent lighting has a 60 hertz vibration, and it interferes with the electronics. The patients have to be a certain temperature. We have to measure and document their skin temperature. So out on the field, everybody has elevated skin temperatures, and sometimes it's wet and rainy, and electrical equipment out there that's just got exposed wires, not very good. Needed something else. We need an enclosed system and a way to do it. And so I asked myself, well, if EKG and echocardiogram are looking at the same thing, but just slightly differently, why can't we have an analog? Why can't you take the EMG and create a Blink Reflexometer that looks at all the same parameters, but through videography? That was a legitimate question. The vision was there, the technology hadn't caught up until about 2008 or 9, which is when I was with MUSC. And they have a Foundation for Research and Development, the FRD, and when you declare something to it, they do try to help you, but really back then they didn't have the resources to do it. It was just sort of like, great, you have this invention, bring it to us when it's ready. And I said, well, I was kind of hoping that maybe you guys could give me a hand here. And they really didn't. But the nice thing is after 18 months, you have the right to go back and ask for it back. So in 2011, after I filed my P12, 14, 16 or something like that, I can't remember what the number was, I went and asked for it back. And Dr. Jesse Goodwin said, do you want to talk to the Institute of Applied Neurosciences, because I think they might be interested. And that was actually my home department, the neurosurgery department. So I took it to Bruce Frankel and Sunil Patel, and they looked at it, met with Mark Semler. They loved it, loved the idea, and liked the science behind it, and took it back to the founders, the funders of the Institute for Applied Neurosciences, which is been renamed the Zucker Institute of Applied Neurosciences, and off we went. So what are we looking for with the blink reflex? We are basically looking at different parameters. When you are looking at somebody and they're blinking, what you're not seeing is that there's side-to-side differences, depending on why they're blinking. If it's a spontaneous blink, it's probably going to happen at the same time. However, if it is a menacing blink, say I come out and I try to launch a punch at you or something, or if I take a Q-tip, if I puff in air near your eyeballs, something, then there are going to be side-to-side differences that are very subtle. And we capture this with videography. And what Kugelberg back in 1952 was able to do was identify there is an R1 component, which essentially is the electrical signal to tell the muscle to move. The R2 component, which is the muscle actually moving and generating the blink. And then there's a recovery period. And sometimes there's a pathological R3. And what we're looking for is we typically only stimulate one side. And so if we stimulate one side, how does that translate to the other side? Are there side-to-side differences? Is there a difference between when the blink initiates? You don't think so, but there are. There's about 20 parameters that we look at to see whether there is a change, whether it is within normal limits, which is like one of those medical terms that we love to use, and we really don't have any good ideas as to what it really means, because I think it evolves at times. And so what we're looking at is a very high-speed capture of the differences in those parameters. So the first indication that we went after is to be used in mild traumatic brain injury. Pretty obvious when you've had a moderate to severe brain injury. Those people are pretty easy to identify. And with radiography, whether it's CT scans or MRI, you can see the changes on the brain scans. The hard part is we really just didn't have a place to describe mild traumatic brain injury, or what we call concussion. And concussion is kind of a term like headache. It's very subjective. We're starting to put more parameters on it. There are entire collectives of really smart people who get together in places like Zurich to discuss how we should describe as someone is having had a concussion event. So when you are able to look at the blink at a baseline when they haven't had any injury versus right afterwards, there is a distinct change in those parameters. And we've been able to identify what those changes are. And it's pretty impressive. In about 20 seconds, we can capture those parameters in a series of puffs and blinks. And within 1 minute, the answer is printed out to see whether the parameters are definitely changed from baseline or not. And it's not a small interval change. It's actually, in some cases, a complete flipping of parameters. And so, it was definitely, it was not just a dose-dependent response, it was a threshold response, which was what we were looking for. And we were very happy to have the data come out that way. We require a baseline on everybody prior to their being injured. So I'm going to take you back and let's do a little history lesson. If you were the first person to invent the blood pressure cuff, blood pressure changes in all sorts of situations. It's when you're laying down, it's different than when you're standing up. It's different when you're active. It's different from when you just have high blood pressure at a baseline. But how do we know that? So the first person who invented the blood pressure cuff had to go and test a lot of people out. And you had to test them in a lot of different situations. Before we can sort of say, for most average adults, if you're under 120 over 80, you're considered normal. I sit at about 105 over 60. That's normal for me, and that's acceptable. Other people are much lower. If you have a spinal cord injury, you're going to be lower than that. It's fairly normal for those people to have 80 over 40, 80 over 50, or even lower sometimes. But, the minute they stand up, everything goes down and they will pass out. That's part of the reason why we don't always stand them up in a standing table. When you have that blood pressure cuff, you do have to get some population basis. We don't have enough population data from EMG Blink because it's uncomfortable. It requires an ambient room. And so we're having to reinvent this thing. It literally is a brand new fifth vital sign in the future because there are implications probably over a lifetime that we can talk about because I think different parameters of the blink reflex are reflected in parts of different neurotransmitters and their pathways. Why am I successful?
Why are you successful? Yeah.
I'm still alive. The fact that I'm alive means I'm successful. And I would challenge everybody to think that. If you're still alive, you're successful. You managed to live to this day, and your genetic pool allowed you to become alive this day. What you do with that, and to the degree that you are successful, is all up to you. It's what you want to believe.
Are there any failures that are particularly important to you?
I don't really think of failures. I think of them as learning opportunities to move on. But at the same time, as kind of an engineer, I think that there are failures, but failure is not an emotional thing. It's a point on a hysteresis curve. You have yield and break, and that's failure. And at some point, some people are more elastic and they come back to baseline. What challenges have I faced? I think, it's funny, I talk to my girlfriends, and most of them are very professional people. It seems like women have to expend a lot of extra energy, or as my friend Jesse Goodwin says, extra calories, in order to get other people to listen to us. I think it's just really frustrating. We're all trying to get to the same end, but sometimes we just find ourselves saying things 6 different ways, trying to make an impression, and inevitably, there's the one guy in the corner who's been listening to us, paraphrases it, and all of a sudden all the ears perk up. Oh yeah, it's brilliant. And you're just sort of frustrated. Those are just sort of the typical barriers that we deal with. And it's, like I said, it doesn't break me. It's just we have to expend extra energy. I actually enjoy problem solving. I think there's some folklore that maybe I'm part vampire, like how do you stop a vampire? You give them a puzzle because they can't proceed unless they have to fix it. And that would be me. I sort of look at everything as a bit of a puzzle, which is devastating in interpersonal relationships because you just shouldn't figure people out. That's just bad. But in terms of actual problem solving in reality with known metrics and things that you can deal with and try to figure out, I like problem solving. And to a certain extent, I sort of have approached my board meetings as a problem. I have learned, there have been times when I've been just really ineffective too. And it's just a process. I've had to deal with my own inability to understand that maybe they just are not capable of hearing me in that way, and I need to phrase it differently. Someone who really enjoys problem solving is going to be the person that is destined for innovation.
Do you have an approach to problem solving that you've kind of employed or honed over the years?
The process depends on the question I'm asked. What gets me from point A to point B in the shortest amount of time possible? And even in medicine, I practice a certain way. If I can, I'm going to address the pathology. If I don't know the pathology, but there seems to be this other thing, I'm going to address the symptom for now and see if anything comes out. See if I can get more information. But at the end of it, if it's like a moving target, and I do have some patients who are like this, I literally tell them, you know, you just have to be different, don't you? And if you are not making improvement the next time I see you, you have to fire me. That really tells me that we're having a dialogue. I'm not going to just chase you. You have to come back and tell me that I'm doing something right or you need to leave because I'm not good for you. When we move forward with any project, if I'm working with a team, we always talk about it. If something just doesn't work, somebody suggested, okay, well, we tried that, let's move on to the next thing. It's not really pejorative. I mean, I think people really do get their egos and their emotions wrapped up in certain outcomes. And to a certain extent, we just have to remove ourselves from what that outcome is reasonably. You know, you can't move to that next place unless you have personal investment in it. But the personal investment also has to line up with the reality of what you get, what information you get at the end of it. In terms of problem solving process, I try to, so I have a 14-year-old, and teaching him the problem solving, especially with new math, is interesting. It's really about, well, what do you know? What unknowns do you have? And how can you take what you know to figure out enough of the unknowns so that you can approach some semblance of an answer, right? I mean, this is algebra, right? You have to have as many equations as you have unknowns. I mean, that's simple as that. These are all the lessons that you learned in, grade school and high school. They're still relevant. So what is innovation? There are different types of innovation. There's innovation in the process. There's innovation in redefining the problem. There is also innovation in finding out what we can do with what we have. And that becomes a very interesting question. I don't know. I guess I'm constantly innovating. I don't even think about it. I mean, most women putting on their makeup probably reinvent themselves, 6 times over in a year. And so I would say we're all innovators. You just have to find the ways that you are innovative and utilize that purpose in a different way. I mean, every time I open my refrigerator to figure out what I'm going to make for dinner, that's an innovation process. Because, when you have a jar of capers, 3 mushrooms, and mysterious items that are hopefully not taking a life of its own, you have to figure out what to do with all of that, or call for takeout. But the great thing is when somebody drops by, you have to figure out, oh crap, do I have a beer and something that I can make to eat? Well, great, that's innovation right there. So there was a young innovator who had a reasonably good idea, but not all the pieces are in place yet. If they happen to be Charleston, I would say pitch it to Zion. Go ahead, give Mark Semler a call or his team and say, hey, I have this idea. He's going to ask you a series of very enlightening questions as to, well, what's the reach? When would you use it? What's the downfall? Where is, all the usual questions that are reasonable. And they are still sort of defining what the important questions are. I went in with a big ask, but it had a big upside potentially, and so they were willing to play with me. I think it's worth going to a person like him. It's worth going to other inventors. The thing that I would say is, don't be afraid to protect your brain, protect your intellectual property. And it is. It's one of the few things that it's a product of your mind, and you have a right to it. Don't be quick to give it away. But at the same time, don't be afraid to talk about it either. Because if you know enough about what the secret sauce is, that's the thing. You always want to keep the secret sauce in kind of like the Coca-Cola safe, right? There's 2 keys and nobody knows who has them, except you own them. But feel free to just talk to people, get their thoughts, and find out, does this thing already exist? Go to the USPTO site, that's the US Patent Trade Office, uspto.gov or something, and look it up. Is this and understand, is this a patent or a copyright? So for example, the device has a couple of different parts. There's the patent on the device itself, which is all of the hard triggers, but there are software pieces, which are copyrights. Now, some of the software is rolled into the actual patent because it drives it. So it's like your iPhone, right? You have an iPhone, which comes with the hardware, and the driver, which is all the software, the iOS that runs it. But you then add the apps onto it. And so if you understand some of those things, that's very helpful. And don't be afraid to learn something about business. Be a good accountant. Understand how much money is going in and coming out. Understand where your budget is and figure out if it's going to work. I mean, FedEx costs probably $500 million to get off the ground, but it's ubiquitous and it's a terrific concept. Don't be afraid of how big the ask is, as long as there's an upside that is bigger on the other side of it.
What's your 1 or 2 indispensable tools you have to have?
My iPhone, probably. It is my prosthetic brain, unfortunately, but I do use it productively. I don't check it incessantly. I'm not on social media, so don't try to find me. I think I have a LinkedIn profile, but I will never check it. You can send me messages, but know that it's going into a black hole. No other device allows me to learn in real time. I can literally open it up. If there's something I want to look up, I can go to some browser and ask a question and get enough information to figure out what I need to do with it. I am now my best travel agent. I can make a recipe for killer coleslaw. I can do all sorts of things just with having information at my fingertips. And it actually manages to keep me on time. I mean, if I always tell people, please send me an Outlook invite, because if it doesn't alert me, I'm starting to feel that part of my brain atrophy. I got a test for that. That will be interesting. But see if the memory cell is also related to my blink reflexes. But I think that would be one. But then the other thing, the brain in between my ears, that would be my indispensable tool. And a good attitude. I look for team members who first understand what it is that we're trying to create. Number 2, they believe in the cause and the benevolent end that we're trying to achieve. That they do recognize where their place is in a team. That I had to learn. I've had to figure out that not everybody who joins a team necessarily has their heart in the right place, and it ends up interfering with the process of getting to the end product. And I also look for people who have their hearts and minds firmly established in reality. I used to say to people, this is where your fantasies butt up against my reality. And it's because I think when people come to me as a physician, they think magically I have x-ray vision and everything else, and I can just tell them from their chief complaints, no, this is a process. I have to understand what it is that you're going through. And it's the same thing with a team. We have to all be on the same verbiage. And I've also learned that a good contract really delineates all of our roles very clearly. And I don't want to be that legalistic, but I've also learned, what is it, good fences make good neighbors or something. Those are some of those lessons that I've had to learn. For me, it's It's always easier to work with people who are smart, and especially people who are smarter than me. I really am very grateful that I've had the luxury of working with a lot of people who are a lot smarter at their little niche than I am. So how did I come up with the device and the engineering, and was I always an engineer? I'm Asian, so I'm probably always an engineer, but that would be a stereotype and probably apropos. Although, kind of funny, I digress right now. I always ask the medical students that I'm interviewing, what was my college major at the end of it? And, it's either biochemistry, engineering, or math. And it's none of those. I graduated from the same college department as Bruce Lee. So you can all look that up. It's really cool. But yeah, at some point I needed to create the engineering bit of it. I am not an engineering by education or by trade, but I needed to figure that out. And fortunately, when I took my idea out of FRD, I was sort of left with this problem of, do I go to Clemson and talk to their biomechanical engineering department and figure out how I can put together a team but protect my IP, intellectual property, et cetera? And fortunately for me, within a week, I ran into Mark Semler, who is now the CEO of the Zucker Institute of Applied Neurosciences. And he said, I can make that for you. He is an engineer, and he says, I can put together a team, we'll figure out. This is just a lot of little problems that we just have to task through now. The original concept of the device is basically something that you put your eyes in, that covers it up. And there is clearly something that puffs into it and then elicits the reflex. And there's a video that captures it on the back end. And so no matter what the device looks like, it's going to have those elements. And there's a computer that processes what it's looking at. Our original device, and it's going to continue to evolve. It's kind of like your stereo. You went from a big system, or the TV, right? You went from a big TV set, now you can watch everything on your iPhones. Again, there's a lot of new innovation that's going to go into what that looks like. But the basic idea is, how can we enclose the eye area and elicit that reflex so we can examine the parameters and give an outcome to someone who's looking at it. The next steps are for the first rollout, which is the concussion. It would be great for us to be in more sports. The more brain cells I save, the better. And yes, it's sexy to be in professional sports, but the ones I'm concerned about, because I'm a mother, are the kids. Your children are so vulnerable, and it is a terrible thing for them to sustain continued brain injuries. And we don't think about it, but I mean, you're in soccer. If you hit the ball about 1,000 times, then you probably sustain some sort of chronic traumatic encephalopathy. I mean, we don't think about it, but it is true. We want them to be in sports, to potentially get the scholarships. We just want them to be in sports to enjoy it and be fit. It's my commitment to exercise as well. But at the same time, we want to make sure they're safe. And you can't wrap them up in a bubble. You can make it better and safer. And that's what I'm trying to do with that. Other future uses, and I kind of alluded to this, is the idea that I think a lot of these parameters are related to the different neurotransmitters, and we can eventually look at an indication where this is in every office, either as an app, in some form, resembling what we have, to where we can say, you're starting to show some signs that are in the dopamine circuit, and we want to just continue to monitor for Parkinson's. Or I'm starting to see some concern with vascular dementia because these parameters are changed. We don't have that data yet, but I think eventually we're going to get to that point where we can differentiate between all of the different parameters and figure out what that looks like. This is Nancey Tsai, and those were my notes on innovation.